Okay, we're recording. So, the first thing we're going to talk about is absolute value. Okay, y'all on page 4 of your notes. All right, here we go. So, the absolute value of a number is its distance from 0 on a number line. It's always positive. Okay, so let's draw a number line here. If I go 2 units to the right, I get to positive 2. But I could also go 2 units to the left, and I get to negative 2. Think about like a ruler. There's no negative numbers on your ruler. A car, when you drive in reverse, it doesn't take miles off your car, right? So distance is always positive, no matter which direction you go. It doesn't flip the sign, it just makes it always positive. Okay? All right, so number 1 there said evaluate the expression, the absolute value of w minus 4x if w is negative 4 and x is positive 2. So let's plug in what we know. Absolute value of negative 4 minus 4 times 2. Four times 2 is 8, so I have the absolute value of negative 4 minus 8. Negative 4 minus 8 more is negative 12. The absolute value of negative 12 is positive 12. Okay, number 2. 10 minus the absolute value of x times w. Again, let's plug in what we know. X is negative 2. W is negative 4. Negative 2 times the negative 4 is 8, so I have 10 minus the absolute value of 8. Absolute value of 8 is just 8. So I have 10 minus 8, which is 2. Okay, questions on any of those? Okay, so those two guys are expressions. We just plug in what we know. The bottom, or the next thing there, says what happens if it's an equation, an absolute value equation. The equation has an equal sign with it. So if we're going to solve an absolute value equation, I have to get the absolute value completely by itself first. Then I'm going to separate the equations into one positive and one negative. I'm going to solve each equation, and then I'm going to check my answers. You have to check your answers. Sometimes we do everything right, and we end up with an extraneous solution. Extraneous means it doesn't work. We did all the math and everything correct, but it doesn't work. Okay? So, let's figure out why we get two equations. So if you look right there, it says the absolute value of x plus 3 is equal to 5. That means the distance that x plus 3 is from 0 is 5 units. Okay, let's think about that for a second. So here I am at 0. I can go 5 units to the right. And when I go 5 units to the right, I get to positive 5, right? But it also said that x plus 3 was 5 units away. That means that x plus 3 is equal to 5. We got to the same spot. Whoops. I wrote too big. Okay, well, I could go 5 units to the left and get to negative 5. That's also where x plus 3 is as well. So x plus 3 is equal to 5, or x plus 3 is equal to a negative 5. Okay, what do you notice? What do you notice about my original equation, this guy here, and that guy there? Kayla, what did you notice?
Everything inside the absolute value symbol stayed the same.
Yeah, exactly. Everything inside the absolute value symbol stayed the same. They all have x plus 3. All have x plus 3. The only thing that changed was the sign out front. I have one positive equation and one negative equation. Okay, well, let's see what happens when we actually solve this guy. Okay, so if I were to subtract 3 from this guy, x would be negative 8, right? Negative 5 minus 3 more. And if I subtract 3 from this guy, x would be equal to 2. Now, you should notice that those two are distinct numbers. Okay? It's a negative 8 and a positive 2. We didn't end up with just a plus or a minus 8, and we didn't end up with a plus and a minus 2. Do you see that? Usually, they are two distinct numbers. Okay? So, my two solutions are negative 8 and positive 2. Now, I could go in and check those. Negative 8 plus 3 is negative 5. Absolute value of negative 5 is positive 5. That guy works. Positive 2 plus 3 is 5. Absolute value of 5 is 5. That guy also works. Okay? Do you see why you get two equations? Okay, questions so far? All right, let's look down at number 3. Thankfully, this guy doesn't have a absolute value in him. Let's just go ahead and solve him. What would we do if we were going to solve this guy? Add 1. So 4x is equal to 12. And then divide by 4. So x is equal to 3. Okay, well, the tricky thing about absolute values is we can't distribute into them. Okay? They're their own grouping symbol. If you looked at the beginning, your first page of notes, it said GEMDOS, right? And no, that's not a typo because we have more than just parentheses. We have grouping symbols, and an absolute value is a grouping symbol. So we have to do everything inside of our grouping symbol before we can move on. So if you notice, these two are strikingly similar, except for instead of that x, I now have an absolute value. So under my steps, it said get the absolute value all by itself. That's what I'm going to do. All right, so I'm going to add 1. 4 times the absolute value of 7 minus y is equal to 12. Just like in number 3, I'm going to divide by 4. So I have the absolute value of 7 minus y is equal to 3. I just did the first step. I got the absolute value completely by itself. I still have 3 more steps to go. Okay, so step number 2 says separate the equation, 1 positive and 1 negative. The guy inside the absolute value doesn't change. I'm scooching as best I can. 7 minus y is equal to a 3. You drop your absolute value bars. Or 7 minus y is equal to a negative 3. Make sure you flip the sign. Oy, oy, oy. There. Sorry. Okay, let's solve this guy over here. Let's subtract 7. Negative y is equal to a negative 4. Divide by negative 1, so y is equal to 4. We know we have to check it. When you check it, you don't have to show me all your work for checking it. So you can check it in your head, and I'm okay with that. But make sure you check it. So if I plug 4 in to my original, 7 minus 4 is 3. The absolute value of 3 is 3. 3 times 4 is 12. Minus 1 is 11. So this guy works. Okay, subtract 7 on my other equation. Negative y is negative 10, so y is positive 10. Let's check it. 7 minus 10 is negative 3. Absolute value of negative 3 is positive 3. Times 4 is 12. Minus 1 is 11. They both work. This guy has 2 solutions. Do they both work all the time? No. One can work and one cannot work. They can both not work. Okay? Questions? Yes, Kayla.
What happens when they both don't work?
We just write no solution. Yeah. Good question. Okie dokie. Ready for another one? Scoochy, scoochy. Here we go. Number 5 says the absolute value of 6 minus 4t plus 5 is equal to 0. What do we do first? Step number 1. Subtract the 5, right? Get the absolute value all by itself. So I have the absolute value of 6 minus 4t is equal to a negative 5. And I'm going to write no solution. Why? Brady, what'd you say? It can't be negative, is that what you said? Not quite. Keep thinking. Hold on. I want to call you Catherine, but I don't think that's right. Don't tell me. Samantha.
Because all absolute values are
Yes, all absolute values have to be a positive number. I'm going to call you Robert. Is that correct? Is that what you were going to say, Robert?
Or something similar.
Something similar to that, yes. So all absolute values are positive numbers, right? You're doing a distance. I can't get an absolute value equaling a negative number. I can't go a distance of -5. Okay, well, what if you say, okay, I didn't see that. When you go to solve it, neither one of your answers will work. Okay, so you'll get some funky answers and they won't work. Sound good? All right, now, it's just a negative number. If you get an absolute value all by itself equaling just a negative number, then it's no solution. If this guy had a variable with it, we could still do it because that variable might be negative. Does that make sense? So look at number 6. Is the absolute value by itself yet? No. So let's move the 3. So see how that guy has a 2y and a -3. So we have that -3 there. That's okay, and we can still go because we have this positive 2y here. I almost went to the board and pointed, but then those guys couldn't see it. This is really hard to try to train my brain to teach right here. Okay? All right, our absolute value is by itself, so let's separate it. 8 plus y is equal to, and I'm going to put some extra stuff in so you can see the positive and the negative. Positive 2y minus 3 or 8 plus y is equal to a negative 2y minus 3. Okay, now I put them in parentheses because essentially we have to remember to distribute the negative for the negative guy. So over here it doesn't matter so much, but on this guy we have to distribute the negative. So we have to flip both. Does that make sense? So when we do the negative one, you have to flip both of them. So 8 plus y is equal to 2y minus 3. I'm just going to solve one the whole way through. Add 3. I get 11. Subtract y. Get 1. So don't change this side because this whole chunk is going to be positive. That whole chunk will be negative. Okay, think about it as like one chunk. That's why I put parentheses around it. Okay, let's check this guy before we go any further. 8 plus 11. 19, absolute value of 19 is positive 19, plus 3, 22, 2 times 11 is also 22. So that guy works. When we get a negative over here, the negative has to be distributed. So I get 8 plus y is equal to a negative 2y plus 3. So it flips both of them. Okay, if I solve that guy, subtract 3, subtract y. So 5 is equal to a negative 3y. I get a negative 5/3. Okay, when we go to check that, that's kind of a gross thing to check, right? Negative 5/3. When you check them, you don't necessarily have to do all of the algebra to check them, okay? We can logically think through this guy. So, no matter what number I put in for y, say I put a negative 5/3 in there, right? When I add 8 to it and then take the absolute value, is that positive or negative? It's positive, right? Even if I put a negative number in for y, this whole thing as a unit will be positive. And then when I add 3 to it, it just gets even bigger positive, right? So no matter what I put in for y, the left-hand side will be positive. If I put a negative number in on the right-hand side, will it ever be positive? No. So will negative 5/3 work? No, because even though I put a negative here, this side gets positive, the right-hand side will never be positive. So this guy does not work. So you can end up with one solution, you can end up with 2 solutions, or you can end up with no solutions. And that's okay. But that's why you have to check. Okay? All right. One more example. Nice. All right, last one, number 7. Is the absolute value by itself yet? No. What do I have to do? Divide by 3. Remember, I can't distribute into an absolute value. Okay? Sometimes it works, sometimes it doesn't, so just don't do it. Okay? So I get the absolute value of p minus 5 is equal to 2/3 of p. Got the absolute value by itself, so now I'm going to separate it into my 2 equations. One's positive, p minus 5 is equal to 2/3 p, or p minus 5 is equal to a negative 2/3 p. Okay, how many of you really love fractions? Oh, they're so good, I love them, they're my best friends. Right? That feels a little overwhelming at the moment, would you say? Yeah. Way to go. First day back doing math in 5 months and you gave me a fraction, lady. Right? Do we have to keep the fraction? No, we could get rid of it, right? What could we do if we wanted to get rid of our fraction? We could go to a decimal, but then it might get a little crazy. What else?
Multiply by 3.
Yeah, multiply by 3, right? If we just get rid of the denominator. And multiply everybody by 3. Distribute it. Now we can distribute it because the absolute value went away. So I have 3p minus 15 is equal to a negative, oh no, excuse me, a positive 2p. Okay. Combining like terms, I'm going to subtract my p over, so 3p over, so I have negative 15 is equal to a negative 1p. So p is 15. Let's check it. 15 minus 5. 10. Absolute value of 10 is 10 times 3. 30. 2 times 15 is also 30. That guy works. Okay, let's do this guy. Distribute my 3. So I have 3p minus 15 is equal to a negative 2p. Subtract 3p. So negative 15 is negative 5p. So p is 3. Oh, I didn't check it. Let's check it. 3 minus 5 is negative 2. Absolute value of negative 2 is positive 2 times 3. 6. 2 times 3 on the right hand side is also 6. Okay. Questions on anything we've done so far?